Hello students, now I'll discuss new Cartesian sign convention. A sign convention is very important in ray optics because you see the image may be real, may be virtual. How will denote, how will understand? By putting plus or minus sign, we can identify whether the image is real or virtual, whether it is erect or inverted, magnification more or less, real or virtual. These things are denoted by the sign convention. Whether the image is in front of the mirror or behind the mirror, whether the object is in front of the lens or behind the lens. To get an idea, we use sign conventions. This is very important to numericals and derivations. Now, what are the assumptions made? Sign convention. The first assumption is the ray should travel from left to right. Is the first assumption. Okay, the ray should travel from left to right. So this is the incident ray. The ray should travel from left to right. Same with the lens. This is the incident ray. The ray should travel from left to right. Now all the distances should be measured from the pole. Distances should be measured from the pole if it is a mirror, and distances should be measured from the optical center if it is a lens. This O is called the optical center. What is O? O is the optical center. Optical center. And what is P? P is the pole. So distance should be measured from the pole for mirror and from the optical center for lens. Now suppose this is the object, something is kept here. The distance from pole, so like this, distance from pole, this is the distance. Now whether it is plus or minus. Now since the distance measured opposite to the direction of incident ray, so this distance will consider as minus. Why it is minus? Because the distance measured in the opposite direction of the incident ray. If the object or the image is somewhere here, the distance from pole is, this is the distance. A direction of measured, this is the direction from pole to this. The direction of measurement and direction of incident ray, same direction. So here we take distance as positive. Okay, distance is positive if the direction of measurement and incident ray are the same direction. Same we apply here. If the object is here, distance is measured from the pole. So this measurement of distance and measure an incident ray in the same direction. So this distance you can take as positive. Okay. Now if the object is somewhere here, so the distance from the optical center, this opposite of the incident ray, you see this is the incident ray, is the incident ray, the opposite of the incident ray, then this distance is taken as negative. Okay. Next point, if the object or image is vertically upward, if the object or image is vertically upward, then height is taken as positive. Okay, height is taken as positive if the object is vertically up from the principal axis, and if the object or image is vertically down, if the object or image is vertically down from the principal axis, we take height as negative. Okay, we take height as negative. So if it is vertically upward, we'll take height as positive. If it is vertically downward, we take height negative. Okay, distance, if the distance is along the direction of incident ray, then positive, opposite direction of incident ray, then negative. Now apply this idea to different cases. Suppose concave mirror. Let us draw concave mirror. You see, for concave mirror, you have to solve numericals. For concave mirror, this is the mirror, this is the pole, this is focus, and this is center. So this distance from pole to focus, this distance is called a focal length. So focal length plus or minus, focal length will be minus, because light will come along this. This is the incident ray, light will come along this. The focal length is minus. And so this distance is what? From pole to center. This is called radius of curvature. Plus or minus, this is also minus. Okay. But for convex mirror, this is the convex mirror. This is the convex mirror. Okay. This is the convex mirror. This is the focus. So this distance from the pole, focal length. Incident ray is this. You see, this is the incident ray. And this is the focus, same direction. So a focal length is positive. And this is the C center of curvature. This distance radius of curvature. This is also positive. Now you consider lens. For convex lens, this is the incident ray. After reflection passes like this, so this is the focus. So this distance is the focal length. The focal length is positive because incident ray and distance the same direction. And for concave lens, okay, this is the incident ray. So after reflection it will go like this. This is the focus, the measurement optical center. This is the focus, focal length. This is focus, so this distance the focal length. So this focal length will be what? The focal length will be negative. Why negative? Opposite to the incident ray. Thank you.